Hello, everyone. I think students are still coming, so I will begin in 1 or 2 minutes. Okay, thank you. Okay, let's begin. So, so if you have any question during the class, please feel free to unmute yourself and ask. But you can also choose to type in chat. Okay, so we can discuss also. I will check chat from time to time. So this course is CS 334 and 534 networking. Okay, so computer networks basically, right? And we will be using a free textbook online. Okay, so this link is already in the course syllabus and also so on the Canvas page. So this is our course website on Canvas page. Okay, so you can get the textbook link here. So if you look at the textbook here, you can see there's online HTML version, whatever you would like to, whatever you prefer. You can read it using like in the website format. You can also read it using the PDF. It's loading. It's a little bit slow, so let's continue. And there are also like a mobile version, which maybe you can watch on your phone. So that's very easy to use, and you don't have to buy any textbook. And here is a PDF version where you can easily connect to where you want to check. Okay, so, and we have two TAs, right? So one is Jalal, one is Nancy, and the office hours have been shown here. Okay, Jalal is Friday, okay, Nancy is Wednesday. Okay. And I think Jalal has shared the Zoom link here for his office hour. Nancy will share this shortly. And this is our course, Zoom link. I think you should all know this now, right? So, because we are connected here. And we will periodically update the PPT files here in this dynamic syllabus. And so before we move on, let me briefly let the TA introduce themselves first. Okay, so because this course is associated also with labs, and the TAs will be helping you intensively to complete the labs. The labs we will be using Cisco Packet Tracer. And Jalal, are you here?
Yes, Professor.
Okay, so the stage is yours. I will mute myself and let you introduce yourself. Thank you.
Hi, everyone. This is Jalal. I'm a PhD student at the Computer Science Department, and I will be your TA with the Mansi. My office hours Friday, 1 to 2 p.m. And I will guide you in some labs. So please, if you have any questions, you can send me on Canvas directly anytime, and I will reply within a day. Thank you, and wish you all good luck.
Thank you, Jalal. Messi, are you here?
Yes, sir.
Yeah, can you introduce yourself? Thank you.
Yes, sir. Yeah. Hey, everyone. I'm Mansi. I'm master's student pursuing computer science. I'll guide you in labs. You can reach me out for assistance via Outlook, and my mail address is here, mansi17@uab.edu. Yeah, my TARs are on Wednesday from 3:30 to 4:20. You can reach me out over there. Thank you.
Thank you, Nancy. Okay, so these are the TAs that you can reach to during office hours or make a point, send email, and also during the lab. Right? The lab is on Friday. I think we have the lab session time. Okay, because it's remote, so basically everyone can connect during this time, and the TA will be helping you guys. Okay, And so before we begin, let me briefly introduce the organization of this course. Okay, so we will have those components here. We will have attendance, which is 10%. And to take attendance, we will use Canvas. Canvas has an attendance functionality. Basically, what we will do is we will use this tool. Okay, today I know that a lot of students they are like they have work, time conflicts, etc. So I'm not taking attendance for today, and we will definitely take attendance after the add drop period. Okay, so we will call out your name, and you can also see this on the screen, right? So then if you are here, just let me know. Okay, let me see. There's some chat. Okay, and for the TAs, if you want to leave, you are free to leave. Okay, thank you. And so let's go back. So here we have the overall page where you can download the syllabus, and you have all the course information, the time and the Zoom link. And this is a description of the assignments, basically, since that you need to finish. Okay. Besides attendance, we have quiz. Okay, so we are making assignments in the form of a quiz, online quiz. They are timed. Okay, so that you'd better understand what we teach and go through the slides once before you do the assignment, because it's time. Okay, you don't have a second chance. So make sure you got whatever we taught, right? So and then you start to do the quiz, and we have around 10 quiz. Okay, each like it's not too many, right? It's just 2%, but you know, altogether they're 20%. Right. So we also have a midterm exam and a final exam. These will be timed in-class exams, still using quiz, because I mean we are doing remote, right? So, but each will be 15%. Right? So for undergraduate students, we will have one project, programming project, okay, on socket programming. And so this accounts for 15%. And you can form a group of at most 2 people to work on this project. Okay. For graduate student, we will have an additional project for you to complete. Right. So both together is 15%. Each is 7.5%. Okay. And we also have a very important component, which is the labs. Okay. We will have maybe 6 topics, I think. Right. So and these labs will familiarize you with different aspects of the networking, and we will use a Cisco packet tracer. I think these are actually the software that is used, that is produced by Cisco for like a certificate if you want to, pursue a career in networking. Okay, so it will be very useful. And so that's the overall introduction of this course. Do you have any questions? Please feel free to ask. Okay, if not, let me start with the first slide, which is also shared here, okay, the introduction. So basically all the written assignments and all the exams will be in the timed quiz in Canvas. Okay, so I see one question from a student. What's the structure of the quizzes? Multiple choice? Yeah, it will be mostly multiple choice. Quiz is something like this. So if you have multiple choice and you have like, let's say we have a calculation question, right? You can input a number into cell. These answer will be unique, right? So the quiz will automatically grading it. Right? So sometimes we will have very few like other questions that may need you to, write something which different student may have different answers. And in that case, we will have to mark them, right? So the TAs will mark them. Okay, so most of them, like if it's multiple choice, and it will be automatically graded. Yeah, so for programming, actually it's free. Okay, I mean the language, whatever you want to use. Okay, I think by code, I think the student means programming language, right? So we will introduce C, C language, C socket API, but you can use Python. I think the TA will also cover the Python API because most of students may be more familiar with Python. Okay, so whatever language you're comfortable with, it's the same basically. Python wraps the API, okay, of C for them, right? Java, I think you can also use Java. You can find the socket programming API for Java, then you can use Java also. Right. So we don't limit your language. Okay. So the concept actually is above the language. Right? So socket programming, TCP, UDP, those concepts. Okay. So I believe every language has its own library that you can use. So the important thing that you need to demo to the TA that you complete this program, right? And you can, so it functions, right? So if we ask you to transmit something and get some response, if the whole workflow works, then that's fine, right? So for example, we will provide the server end program, maybe written in C, but you can use Java or Python, right? So it's actually just it's a protocol, right? So in networking, so both ends can have different languages as long as the content transmitting the network is the same. They can understand each other. So the language is not a concern. Okay. So everything will be done through Canvas. Yeah. So the answer is everything will be through Canvas. And another question, for database scripting, I don't think we have any database scripting. I don't quite understand this question, but if you can send me email to clarify a little bit so I can answer offline. Okay, so yeah, we will provide some introduction of the API of the programming. So you will not be shocked suddenly you have a task that we will provide some hints like what you can look to, what you can study, right? So and then you get familiarized with circuit programming, for example, right? And then you try to use them to complete the task. Okay, so yeah, so that's pretty much the questions. Let me, I see one more. Okay. Oh, so there, I think it will be very soon, within a month, we will have the first programming project out. Okay, so one student asked me about the timing. Okay. And for the first week, we will not have the lab. Starting from the second week, we will have like weekly lab. Okay, and the lab including the lab assignments, also the program assignments, because when we have the program assignments, we will not have lab assignments. We don't want to overload you with two like a programming hands-on stuff together. Okay, so during these lab classes, you can go and ask the TAs for help on questions regarding the programming project. Okay. Okay, let's begin with the first slide, okay, the first PPT. So let me briefly introduce this course. We have introduced a lot already, right? So yeah, so you can, my name is Diane. Okay, you can, here are my information. This is my email. If you want to ask questions, you can make a point with me if the TA cannot answer your questions. Right, so this is my website in short notation. So, and you can call me Da, you can also call me Daniel if it's more convenient for you. Right, so my surname is Yan, so not Da. Okay, so, and whatever you want to call me, okay. And so I do some research in parallel distributed computing, right? So at least using like say Ethernet environment to do distributed computing, right? So yeah, so my research is cross with networking, but I'm more in data management and AI machine learning. Okay, so I'm also teaching the other course of data science this semester. So. And for this course, we will take the approach. So I'm not sure whether you've heard of the OSI model. There are 7 layers of network design because there are some very low level, like a physical level communication, right? But we also have the very top level, app level communication, right? For example, if you want to send some messenger from your app, let's say the Facebook app from one cell phone to another, right? So that's really app level. We really don't care about how they are communicated through the physical layer, right? So there's like 7 layers proposed early on called OSI 7 layers model, okay, from the bottom to top. We will describe also from bottom to top. But in this model, I would like to indicate that these two layers actually now combined with the application layer. Okay, so we are, in reality, we are not using the presentation layer and the session layer. Okay, so these concepts are actually associated with, if you are doing web programming, a session basically means you need to log in and there's like the server will track the session you have, right, until you log out, right? So, but these concepts are all now merged with application layer. Okay, so basically we only have application and transport. Okay, so and a network and data link and physical layer. And the physical layer, we will really keep it really brief, right? So because this is more like double E kind of stuff, right? So we will focus on basically, let me take some, okay. So we will adopt a bottom-up approach. We will take data link layer, network layer, and transport layer, and application layer. So these 4 layers are the key that you need to be aware of. Okay, the course will be centered around these layers. And we will then talk about some advanced topics relevant to these. Some may be crossing layers. Yeah, so yeah, one student asked Chiha, right? So yes, Chiha is more like a data center kind of stuff, right? So it actually cross multiple layers. Okay, so we will see whether we have time to introduce a little bit. Okay, so I don't really have that you know. So basically there are 7 layers, right? So you can memorize them with some efforts. Okay, so basically as the course unfold, you will easily remember them, right? So because we are talking one layer after another. Okay, so for now, even if you have the quiz, actually it's like an open book quiz, right? So we have no way to stop you from checking the slides, for example, right? So for the quiz, as long as you know where to look into, that should be fine. Okay. Yeah. And let me see. By the way, I may not be able to check the chat very frequently, so yeah, so there could be some delay. And why do you take this class? So firstly, networks are really a big deal, right? So right now, frankly speaking, I think students now do not feel it a big deal, right? So we now take it for granted. Okay, so but even for me, I think I take it for granted, right? So, but for like more senior people, right? By that time, network is really a big deal. They see the development of like the phone and the internet, right? So, and then all kinds of apps right now, all kinds of the biggest companies are actually relying on the internet, no matter Google, keyword search, whether it's Amazon, right? So you're shopping online. All these are actually the biggest IT companies are with internet, right? So internet really, I think one important reason is the scale, right? So if you have a lot of people using your app, right? So this is really a way to create a company. Okay, so sending emails and browsing web and sending messages with the peers. I think these things are quite common these days, but early on it's quite exciting, right? So maybe the next wave would be like a virtual reality or augmented reality using like 5G technology. Right? So as the communication is no longer a problem, the bandwidth is no longer a problem. Okay, and it's really critical for both business and society. Right? So these days we using chat for business quite often. Okay, so for customer support and for communicating with people even within the same building, and so networking is basically the foundation of everything now. So for apps and mobile devices, right? For sure that there's a statistic saying that there are more people using smartphones, right? So using apps than using the laptops, okay, using the computers nowadays. Okay, so this is really a really big market, right? So and there's big data and they're using cloud computing, right? So these days, the major service providers are thinking that we don't even need your own laptop, right? So you can have a very lightweight laptop, right? Like Chromebook, etc. Okay, and what you need is like there's a lot of things that are on the cloud, right? So when you need, because the network is so fast, you can save your photo, right? So I think for Google phone, right? So you can save your photo just on the cloud. When you need it, it will load it for you. Okay, and computing you can totally use on the cloud. Use the cloud to do the computing and then show the result on your screen. Okay, so And online gaming, definitely you need a very powerful servers. It's not on your local machine. In the old days, actually, you can be the host. You can host the machine, the game, right? Like Counter-Strike, and the other people connect. Right? So nowadays, so for those online gamings, they have dedicated servers. Yeah, if you have any questions, just let me know. Okay, you can unmute yourself, by the way. Yeah, so okay, the goals of this course is to understanding the networks, especially those, as I said, the 4 layers, right? So you have the application layer, transport layer, network layer, and linked layer, right? So they have different purpose, okay? So in the application layer, you have different apps. Each app is communicating with the respective app on the other party, right? So you really don't care about how the packages are routed through the backbone network, okay? So the application layer, our folks will be different. Okay, maybe you just need to know who you are communicating with and what you are sending, right? So we will talk about this later. Okay, and we also have the transport layer. Okay, so the transport layer is really care about TCP and UDP. It's below the apps, so you can have different kind of apps, right? Using different. I'm sure you heard of the port, right? So port number, right? So usually you have each app using one unique port on the computer. If 2 apps using the same port, then their messages will be mixed with each other, and they cannot recognize the information. Okay, but down there they can all be using, let's say, TCP to do communication. Okay, so the different apps can using the same protocol, right? So in the transport layer. Okay, but the transport layer also don't care about how things are routed in the middle. Okay, and then we have the network layer, right? So the network layer is a backbone internet, right? So actually, it's a dominating protocol these days is the IP protocol, right? So, and here you have TCP, UDP, etc. Okay, and here actually we don't have a lot of diversity. Right? The app will have all kinds of apps. Okay, and these actually cares about how the packages are routed through the backbone internet. Okay, right. And finally, so these are actually IP layer is actually multi-hop, right? So you care about how it routes from outside this building and to the other party in a different geographic location. Okay, and finally we have the link layer. When we talk about link layer, right? So these 4 are the most important. Okay, this is network layering when we mark it. Link layer is really you care about how each link is propagated, right? So you care about the bits are sent over the wire. Okay, and so you don't have the big view of the routing path, right, through one location to another, but between every 2 consecutive spots, right? So how they are linked. So this is what link layer is. Yeah, these are the overview of the 4 important layers: application layer, transport layer, network layer, and the link. Okay, so you need to have a fundamental understanding of computer networks, and so all the way up from bits go over the wire, like the Ethernet, the wide area network. Right? These are the this is the backbone. Ethernet is local in your building, maybe. Right? So in maybe our computer science building. Right? So this is more on the backbone network. Right? So this can also be wireless, by the way. Right? So like if you are using your phone and the 4G, it's actually through the air. Okay, so through a base tower, etc. And so this is down there is basically bits of the information, 0 to 1, passing through hop by hop. Okay, but then you care about how it goes through the web. Then you go to the network layer. Right? So how you go from one host to the other through a bunch of backbone routers. Okay, and finally you care about like application developers, right? How your message are passing through another party, given their, let's say, given their IP address or even this username, etc. Okay, IP address is more care about by the transport layer. Okay, and so you can see that this kind of layered structure has a lot of meanings, right? So when you are developing an app, you probably just do socket programming. You don't care below the transport layer, okay? And when you do physical layer, right? So you design those kind of physical medium, right? So you don't care about how people are sending applications, right? Or whether it's a WhatsApp or it's a Facebook, right? So You don't really care about that. Oh, it's like Netflix, right? So for you developing the physical layer, it's all the same, whatever app is. So this actually is a modularization idea, right? So in this way, different people can focus on different aspects, okay? And there's a, from bottom to top. Right? So this is a high level, this is a physical low level. For us, maybe the physical layer is not so important, not so interesting, okay? So we will get more efforts from link layer up. Any questions so far? Yeah, I see a chat. Oh, so there's a student asking about blockchain. I think the latest question. I may miss a lot of questions before. Sorry for, yeah. So blockchain is a different technology, right? So blockchains, blocks are actually the cryptography concept. Okay, so you have a lot of transactions, right? And you have a block of transactions if you want to commit them, right? So you want to find a code that can connect this block of transactions to the previous block of transactions. Okay, it's more like the application level, the high level logic. Okay, down there is still using the backbone network to communicate those stuff, but it's more like a application level. Everyone has this blockchain, this transaction chains, right? So together, and everyone will do some kind of majority voting. The longest chain is thinking the ground truth. The other chains may be dumped later. Okay, so these are in the application level. It's not really done here in the other level. Okay. You can treat it as one kind of application on top. Okay, it may also need a TCP to do transmission. Let me see. Okay, yeah. So. Yeah, our focus will be on software and protocols. Okay, so how things are communicating. Okay, we will not talk about a lot about physical layer, the hardware. So we do need to let you guys know some common hardware. Okay, so the minimal you need to know about hardware. Right? So especially, let's say, if you want to deploy a network when you move to a new building, right? So how to do that. Right? So we'll briefly cover that. Okay, so. And so we will use minimal theory. So previously, we use a lot of theory. So because in networking, there's a fundamental theory called queuing theory, right? So for routing, those kind of stuff. Okay, so that may be too difficult. We will keep it minimal. We may just tell you the conclusion. And there's also probability theory, right? So like the Aloha protocol, these kind of protocols, right? Share median. If two people talk together on the same median, then the data is corrupt, right? So only one person can talk at a time, okay? So then there's some probability stuff, but we will see whether we want to keep it minimal. Okay, so later in the class. Okay, and let me see. Other things are like the computation. So the computation we may need you guys to understand a little bit. For example, one thing important, you need to understand the kinds of the bandwidth, right? So this is like how wide the link is, right? So whether if you spend let's say 1 second, how much data you can send, right? 1 megabyte or 1 terabyte or 1 gigabyte, right? So this is the bandwidth it carries. This is how wide. But there's also a concept of how fast it transmit, right? So there's a latency concept, right? So the ideal concept is that if you have less routers, then it will be faster. The latency will be lower, right? So this is like if you send a message to the other party, how long the other party will get it, okay? So like a package, it will transmit here, and this will do some routing, decide to go on this link, and then finally go to this, right? So there's also latency and then bandwidth concept. But we will keep it simple, but you need to understand how to calculate it, right? So if you have a device, a router, there's some numbers on the configuration, right? So you need to understand which one meets your need, right? So if it's too low speed, maybe you don't like it. Okay. If you are playing, for example, games. And so we will have hands-on and project-centric. Especially this is good for the remote teaching these days due to the pandemic, right? So we're basically using quiz only for this kind of previously kind of paper-based exams. Okay, so we did some adaptation. All right, this is the recap of what we have. Labs are very important. Okay, so they account for 25%, and the lab session will be on Friday. And the first week we will skip it. We will start from the second week. Okay, so the first week, a lot of students are still deciding the adding drop period, right? So we don't want students to miss the first lab. Okay, so because the first lab is going to be important, teaching the software. the Cisco packet tracer. Okay. And then we will have around 10 graded quiz. Okay, no more than 10. Okay, but, at most 10. So, and after a particular class, if we have something relevant to that that chapter, we will release each quiz around 10 questions. Okay, and you will have a timer, and you will try to answer them within the time. Okay, and we will also do midterm exam and a final exam using quiz. Okay, there will be more questions, right? Like 50 questions and longer hours. Okay, instead of just 10 questions each quiz. Okay, and it's time. So, but the questions will come mostly out of the graded quiz, and I will also give you the coverage of the questions. So we don't want to give you a shock, right? So suddenly there's a new question that's totally difficult, and you never get prepared. We will get you guys prepared, but just to test how much you understand from. Okay, and so for projects, we will have one socket programming for undergraduate students, and one more for the graduate student. Okay, so more like I think it's a proxy. Okay, your Jedi proxy. This will require some multi-threading. We will recommend some results for you to check out. Okay, for the previous one, it's just a standard socket programming. I think every student taking networking will need to understand socket programming. Okay, and finally we will have attendance. So make sure if you have to miss a course, you need to let me know before the class, okay? Because I can take you as a leave. We're using Canvas. Let me see. We use this to take attendance, right? So I need to keep a record before the class. When I take attendance, I see you already taking leave here, right? So basically we will say, hey, you are taking leave like this. Okay, this is missing, right? This is you are here. Okay, let me take it. Okay, so I need to keep that record. Okay, otherwise, if I see something like this, I will take you as a miss. Okay, when I call your name and you haven't asked for leave, right? And for that, we will also, for consistency and fairness, we will not count you if you ask for leave afterwards. Okay? Even if you have very reasonable reasons, maybe you cannot do it because of the fairness. And yeah, the midterm will contain questions all the way till the midterm. Right? So these quiz questions and some lab questions and some additional questions. Maybe I will tell you to get prepared before taking the quiz. Okay, and the final exam will be mainly on the second half of the semester, but we may have some previous questions there. Okay, so get prepared. Any questions before we move on? Let me see. I see some from chat. Yeah, I think this call is recorded. Okay, this lecture, the video will be shared. Okay, and yeah, we will share using YouTube, and we will send a notification through the through cameras. Okay, so there will be a YouTube link that you can rewatch this call. Okay, let me see another question. What did it go from? Oh, there's a question. So for that question, I think from Logan, we will answer you as with the class unfolds. Okay, we don't want to tell everything in the first class, so that will. So another question: how many hours? So the standard hour is maybe I think 2.5. But if we don't have too many questions, maybe we will cut it short. We will decide the time and let you guys know. Okay, yeah. So that's it for the first slide. Okay. Let me open the second slide. I see another question. All right, so yeah, so this is a more relaxed lecture. Okay, so just to give you a brief history of networking, also build a mindset how you understand the networking. Okay, so there's not too much stuff for you to memorize. We will not test you too much on this. Okay, so it's a history of networking. And I will also keep it brief because maybe, you know, at this age, maybe everyone is so used to networking, right? It's no longer like a big deal for every student. So we will highlight some key things you need to know, okay, not the whole history. So yeah, so firstly, what is a communication network, right? So so basically it's a bunch of nodes and apps, okay? So I mean links here, okay? So for example, you have nodes are means of parties that want to participate in communication, right? So, and links are the channels that you can send stuff there, okay? Yeah, I will unlikely ask a exam question in this chapter, okay? So just to tell the student ask this question, okay? But it's important to get you started, right? So have a good mindset about what networking is about, and then you, when you listen to the other stuff, it will not get too strange, okay? So it's actually not just about computer networks, right? For telephones, right? So you have switch in between, right? So if you call a long distance call from, you know, the East Coast and to the West Coast, right? So or you from US to UK, for example, so it's a long distance call, right? So it doesn't happen suddenly, right? So you have something in between to wire the call from one end to the other. Okay, so the telephone is example, computer is example, and in the very old days, even, you know, people in different cities, right? If you need roads to connect them, right? So like letters, right? So this is also the same, okay? And so the messenger is basically mostly information, like along the roads, maybe in early days, you send letters, okay? So telephone, you send your voice, okay? And now computers, then you can send any data. Okay? And so networks are the key for, you know, speed and distance. Right? So we'll see the technology improves. We are shortening the distance and increasing speed in some sense. Okay, and network is really fundamental. Right. So you know, in ancient Egypt, right? So in 2400 BC, you know, when people connect to each other, they're using roads, right? So they're using courier networks. So building those couriers, right? So send us like letters and stuff from one city to another. Okay, the same is like the postal services, right? So and these are actually starting from very early days. Okay, so and even now we have the USPS, right? So it's still here. But the problem, of course, you know that it's really slow, right? So if you want to send a letter these days, you probably will not send other like formal documents. Maybe you're still using the courier or using the letters. Okay, so but mails, right? So but usually if you send the casual message, you will use email, for example, or using some apps. Okay, so because the speed is not so fast, right? This one day, right? Many days or even 1 week. Okay. And in the old days, you can see these in this age, so the reliability is also an issue, right? So maybe there's some like robberies in the middle of the road. They just take all the stuff, right? So you may never receive those stuff. Okay, so yeah, so that's really older days. Okay, and then and in 1837, right, so the telegraph is invented by Samuel Morse. Okay, it's a Morse code. Right? So basically, you can use a telegraph. Okay, so it can propagate through the air for like 10 miles. So I mean, it's much better. Right? So if you weld them together, right, so you can connect, you know, from one location to another, 10 miles plus 10 miles plus 10 miles. Okay, so but it's faster than just using roads and to connect, right? So, but so speed is really slow. Okay? It's more like 10 words per minute. We'll see why. Okay, so we'll show you a demo here later, shortly. Okay, and you can see that from the 1837 to 1985, right? This is really recent. Okay, you know, Morse code is used throughout this period. Okay, telegraph. Okay, so now there's not many people using telegraph. Okay, And a key challenge to encode this information using telegraph is this, right? So telegraph is something like you can have an on state and you can have an off state, right? So you have a signal state or not, right? But we have, let's say we want to present a sentence, right? Sentences are composed of, let's say, letters, okay? So if we want to have a word, each word has a bunch of letters, right? How to represent the letters, okay? So one naive way is to use like this one dot is maybe on once, okay? And if we want to say A is one dot, right? And then some off period, okay? Then B is 2 ons, right? C is 3 ons. We can do this, but we have 26 letters, and sometimes we want to have other, like a comma, etc. Right? So this will be a disaster because you think about the Z, right? It will be dot 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 26 times, right? So this is a unary encoding. Okay, it's really not desirable. Okay, and later, Morse code using the standard binary encoding, which means we use both state to encode. Then you don't have to have like 26 dots, right? So it can be much shorter. Okay. This is more like a dot and on and off is A, off, on is B, right? So you have 4 or 5 letters. Okay, so this is much higher compression, and this also allows a faster speed because when you have on-off state, each state takes time. So here there's a demo. I think in Wikipedia, I think it's a very good example. Okay, so basically you can see here, dot, is short mark. Longer mark is 3 dots. It's like a dot dot dot. Okay, and there's also gap, right? Means off. Okay, it's like a between letters, right? So if you have words, a bunch of words, each is like letters using the Morse code, like here. Let me see. I should make it smaller. Yeah, using something like we just described it, right? So this is A, this is B, and C, etc. Okay, right? So I think here actually both are on. Okay, so this dot is on, this is long on. In between them it has an off. Okay, but you can off for a longer period of time. Right? So Juris might disagree, right? Okay, so you can have a short gap and a long gap, right? So because let's say you want to say, hey, these are 2 different words, right? And let's say you have something like A, B, B, right? So you need to know there's a gap in between, okay, right? So these are 2 different words, right? So for that, you need a little bit more gaps. So you need 7 units of, without any on, right? So if you have a small on and then a small gap, means between 2 letters, and then you have a bunch of, longer term. So these are the binary on states, okay? 1 short, 1 long, okay? And between letters, you have a short off state, okay? 3 time units. And between long, you have 7, like here. Okay, you have 7 short units, okay? Something like this. Any questions? So just I think there are some examples actually here. So this is from A to Z, right? So if you remember, we have A is let me see. A is 1 short, 1 long, right? This is long, short, short, short. B, okay? Right, let's listen. You can see this, right? So this is the long shot, okay? Okay, and when you receive it, you can interpret it using that table. Okay, yeah. So that's pretty much, there's also you can hear clearly there's a gap in between 2 letters. Okay, so this is the between letter. I believe it's a short gap. Okay, so again, those detailed rules, unless you really are interested in them, right? So because not many people are using them. Okay, so unless you have no network, you have no other channels, right? So maybe this, if you know this, you can communicate with it. Okay. Otherwise, maybe these days it's not so useful. Okay, but just to give you an idea how these information are encoded, right, and then sent to type. Okay, then we have the telephone now, right? So the Alexander Graham Bell invents the telephone in 1876. Okay, and there's a key challenge though, right? So let's assume everyone has a telephone line now in the class. Okay, for telephone line, you have a dedicated occupation of their line, right? So you can talk to another party, a third party cannot reuse this one. So that means that you have to connect to everyone. So that's n square complexity. Okay. So what does this mean? Let's take a look at a complete graph. So let me. So this is something like a complete graph. Okay. So basically, everyone should be connected to everyone else, right? So when you call this guy, you use this link. You call this guy, you use this link. This guy, this link. This guy, this. So this actually increases really fast, right? So you can see. So this increment is actually in the order of n squared. Okay, n squared. So the reason is also very simple. You think about this person. You have 4 nodes, right? So this guy needs to have 3 links. Okay. Now, if we consider this guy already handled, we consider this guy. It needs to have 2 links, okay, plus 2, right? And then after this guy's handled, between these 2 guys, they have 1 link, okay? So this is really 1 plus 2 plus 3 all the way plus n minus 1, okay? That number is actually on the order of n squared. Right? So, and the n squared is crazy, okay? So let me, I think this is useless. So you think about it, right? So if you have 1 million people, right? This is common, right? 1 million people have 4 in common. N squared is created. Okay, 1 million is 10 to the power of 6, right? But the square is 12, 10 to the power of 12. But this number is, it's maybe, there's a whole world that's just having billions of people, right? So maybe 10 to the power of 9. So that's 1,000 times in terms of order, in terms of number of people in the world. Okay, so it's like a creator. So maybe this is not affordable, and we are just talking about 1 million people connecting with each other, right? So that's the motivation that we want to have switching, right? So basically, we don't want to have so many wires, okay? And even if you have so many wires, the maintenance is crazy, right? So even if you have very low probability of, malfunctioning of each wire, right? So because there's so many wires, you are kind of keeping replacing wires. And so then switching solved the problem, right? So you still have, let me give a brief, let me see. Switching, I think there's an example page. Sorry, so I think it's gets stuck. Okay, it's because the canvas. Yeah, switch is something structured like this. Basically, it's something saying that I think the time is almost up, right? So we will stop after the switch. Okay, so you have maybe wires like this, okay, and you also have wires like this, and you want to connect people from here to this guy. Then all you need to do is, because you have a wire and this wire, right? You say, hey, this is now connected, something like this, okay, and this person then can talk to this person by connecting this. So you don't need really n square lines. You only need 2 n lines, okay, but you need some people to help you plug the wires, This is kind of crazy, right? So in the old days, as we said here, right? So that's manual switching, and you need to separate call. It takes like 15 minutes if you do cross-country call, okay? So that's also not affordable. Yeah, so, and there are also the trunk lines, right? So this is like the backbone routers kind of concept, okay? So I think it's a little bit late. Yeah, so you have, these are like routers. Those trunk lines are connected with each other, but then you just connect to trunk lines. Then you can switch to the other party, okay? So this is the idea. You can avoid n square curves, okay? Okay, that's pretty much for today. Any other questions you want to ask, please feel free to ask. I will be here for maybe 1 more minute and to answer the questions. Otherwise, I will see you guys on Friday. Thank you. The video will be shared on YouTube, and the link will be shared from Canvas. Thank you. For Wireshark, I think one student asked for Wireshark. Previously, when I teach this course, we actually use Wireshark, but now I think we are using the Cisco packet tracer. Wireshark, if you have interest, you can let me know. We will send some documents to you. Okay, you can study also yourself. But we will see if the Wireshark is interesting. Then if you are really interested in Wireshark, we can make some reduction. Okay. Yeah, if you have questions, feel free to ask. Okay, if not, then I will disconnect. And if you have any questions, feel free to email me. Right, thank you. Have a nice day. Okay, there's one student. So if you really have time conflict, you just send an email to me before each class. Okay, I will, because this is an unavoidable case, and then I probably will approve more than twice of leave. Okay, so just remember to send the leave request before the class. Okay, okay, thank you.